envelope here. And so this is a summary that I will be giving you here. The book has one too, but I don't like that one all that much. So we're going to call this properties of quadrilaterals. And we call them four-sided polygons, right? So that you can kind of have as your title for this page. And one thing you can be sure of is sum of interior angles is always going to be 360 degrees. That's going to be true for all. Right? It's just like a triangle is 180. For a quadrilateral, it doesn't matter what it looks like, it's always going to be 360 degrees. Okay. And I'm kind of going to pair up shapes because they're similar. Okay. So the first one would be a parallelogram. So I will often just do this parallelogram. Okay, that'll summarize the name. That way we don't always need to write out the whole thing. And I would encourage you to have different colors for this section. Right, so parallelogram is a slanted rectangle. And it has two sets of parallel sides. I'm going to use different colors just so it sticks out a bit more. But you essentially have this side and this side. Like the arrowheads tell you that these sides run parallel to each other. And you have these two sides parallel to each other. So that's what the arrowheads mean. I use double arrowheads for these two sides, indicating that those two sides across each other, opposite each other, they run parallel as well. And you also know that the opposite angle, so this angle right here, is going to be the same as the opposite angle across right here. If you use pencil, that's fine. Like it's pencil for all of it. And then this angle right here, I'm going to use a double like that, is the same as this angle across from it. So same angle, congruent, right? And congruent across like that. And then we'll do a rectangle right under it. And we still have the parallel lines, like this one is parallel to that one, this one is parallel to that one. So that's a property that's true for both of these, the opposite parallel sides. Two pairs of parallel sides, if you want to call it that. And notice that diagonally opposite angles are still the same. In this case, they're all 90, right? I know they're all 90, but I'm just showing you that it's still the same as up here. Okay, so I'll tell you what you can know for both shapes. If I asked you to draw one, you need to identify that opposite angles are equal. congruent. Congruent is a fancy word for equal, and it's this symbol. It's an equal sign with a squiggly line on top. That's the symbol for things being the same. And you can say that they have two pairs of parallel sides. They also have two pairs of equal sides, meaning that their side lengths are the same. There's two pairs, right? There's one pair here and one pair this way. So two pairs of equal sides, so they measure the same. And here you have to be careful. You can say that diagonals bisect. They split in half. This is always true. Diagonals bisect. They split each other in half, right? For a rectangle, parallelogram, hold on here, what's happening here? A parallelogram how should I say this? Has one long and one short diagonal, right? A parallelogram, like if you go across here from this angle to the other angle, that's the long diagonal, and this is the short, right? Therefore, not equal in length. A rectangle has two identical diagonals, all equal in length. And one thing that you can write down here, or maybe we'll do too many. We'll do a parallelogram here because I don't want to add the diagonals to the original. It's too messy, right? If you have a parallelogram, we're gonna do the long diagonal with red. I'm gonna do red here, and I'm gonna use blue for the short diagonal. Okay. What we know is that when they meet, these lines cut each other in half. So this little stretch here is the same thing as this stretch here when you're looking at the red, the long diagonal, right? So I'm going to underline long here with red. And the blue diagonal, which is the shorter one, is also cut in half. But you cannot just put one tick in there. You have to say, you have to put two marks on there because you're saying that these two halves are the same, but they're not the same as the halves created by the long diagonal. Okay. And then you have your rectangle here. And there, both diagonals meet the same. They're the same length. Okay. And there you can say that all of the little intersections, like when you cut them, they're all the same length. That's what I'm trying to say there. And something that's particular, so this is something that distinguishes them. The other thing would also be that for a rectangle, it has 4 right angles. That's something that's unique to the rectangle as opposed to the parallelogram. I'm just going to focus it one more time here, folks. So that'll help. And that's it for those two, and I call them their cousins, right? They're related. So parallelogram and rectangle are similar in ways, but also different in other ways, right? So technically, the rectangle would still meet the things of we would still be under the parallelogram criteria, but it's specifically a rectangle because of the 4 right angles in this case, right? So next, I'm going to approach it the similar way as these two. Okay. I have a rhombus. It is basically a square, a slanted square. Okay, so this is what we call a rhombus. And I'll put the square right underneath it. Try to make it look like a square. You have your rhombus and you have your square. We still have the parallel sides going on here, right? You have parallel, parallel. You have parallel. These two are parallel to each other. Let's do the same with a square. These two sides are parallel each other, and these two are also parallel to each other. So if you ever want to draw and identify at least one property, that's the easiest one to identify right off the bat, the 2 pairs of parallel sides. And then we know that this angle is going to be the same as this angle. So it's similar to this angle is the same as this angle over here. And with a square, we have all 90s, but this property is still the same. So something that's true about all of them is all sides are congruent, equal in length, right? Opposite angles are equal as well. I'm just gonna So we know that when it comes to diagonals, we need to be careful here. Diagonals bisect, split in half. And specifically to a square here, you can say that diagonals meet at a 90-degree. That's specific to a square. Okay, diagonals meet at a 90. And we'll do a little square here just to reiterate that point, is that if you have diagonal and diagonal, they actually meet at a 90 here in the middle. They're perpendicular. Okay, that's very specific to a square. That is not the case with a rhombus. Okay, but that the diagonals bisect each other, that is true. And I will just make this here. If you have a rhombus, right, the diagonals there will bisect. So they will cut each other in half, but they won't be the exact same length. With a square, I guess I can just use the same color. They will all be the same cut. If you cut them in half, they will all be the same. Plus, they meet at a 90. That's very unique to a square. That's it for those two. So I just want to go back. If I asked you to draw a rhombus, for example, and identify at least two properties that make it unique, if you were to draw something like this, that would be it. Like you've identified, right, that it has two pairs of parallel sides, and it has two pairs of opposite congruent angles, right? If you didn't want to, for example, let's say you only want to identify the parallel sides, but do not want to identify the angles, you just want to talk about the diagonals, you just insert the diagonals here and make sure the markings are appropriate, right? So that's, and we'll do some examples so you'll get it after. Okay, next we have trapezoids. There are two main types of trapezoids we're going to talk about. There's the isosceles trapezoid, which is basically like a roof cut off, right? Like this. And you have the right trapezoid. You have the isosceles trapezoid and you have the right trapezoid, and the right trapezoid, simply put, has the right angle here on this, the two right 90s on this side, and then on the other side it's one of those, like the pointed ones on the other end. Let's see what's common about them. One pair of opposite parallel sides. other pair is equal in length. Base angles are equal. We'll make that it for, this is mainly for that one. For the right trapezoid is one pair of parallel sides. Two right angles. And that's about it. And so we'll just make the markings on them. So we have one pair of parallel sides, same with the right trapezoid. So isosceles or right trapezoid, they're both the same. I would strongly encourage you to try to summarize this on your study sheet. It'll be helpful, at least the diagrams perhaps. And so we know that they both have one pair of parallel sides. We know for an isosceles trapezoid that this side measures the same as this side, okay? And that the base angles, so this one here, is going to be the same as this one here. And technically by that logic, these two are also going to be the same. So angle, angle. So I don't write down all the properties next to it. You just kind of have to recognize it by the diagram. And here you have the 290s that make it very unique, right? And the last shape, hopefully this will work. So these are the only quadrilaterals you have to worry about that you see on this page. And this is called a kite. And so draw your kite. We're going to make this. And what we know is that the diagonals here, I'm going to use a different color for that. Right, the blue diagonal going across and the long diagonal going down like this. They meet at a 90 here. Okay? They're perpendicular. That's a name for meeting at 90. That's very important. That's why I used a red marker or red pen to mark that they meet at a 90. That's very unique. The only diagonal that gets cut in half is the one that goes from side to side. The long one here does not cut in half. You can actually see that in the diagram. Okay. We know that this side length here is the same as this side length there, and that this is the same as that. So these two measure the same in length as well as the top. It's almost like two isosceles triangles put together, right? There's an isosceles up top and an isosceles at the bottom. You kind of stack them, and that's what you get. And one last marking I'm going to do. I know it looks very busy here. Maybe I'll just draw another version of it where I identify different things, okay? So let's say you draw another kite. I'm asking you to do that. And in this case, you're just going to identify, for example, that these two sides are the same, and that you don't have to memorize all of the properties, okay? You just have to know at least two of each. And also be able to recognize if I give you a diagram what's wrong with it, right? So in this case, you do this, you identify that there's these two are the same, these two are the same, and that this angle right here is the same as this one right here. This is also true. Okay. Do not say that this one is the same as that one, because that's wrong. Okay? These two are the same. These two are not the same. Let's say, let's put it in writing, because sometimes I'll ask you for it in writing. Two pairs of congruent or equal sides and you can say that diagonals are perpendicular. I'll put that word down, perpendicular, meet at a 90-degree angle. That's what perpendicular means. But I think it's important for you to know that word before you leave grade 12. One pair of congruent or equal, right, angles. That's it for properties. If you were able to fit all of this on this page, you did good. And I will do one more thing. I'm going to go back to all of them and tell you something that's true for all of them except for the kite. That way it sticks. Okay, so I'm going to zoom out a bit because you'll be able to see it. So if I have most of them there, let's just go along the edge here. Every time you see a quadrilateral, you know that the two angles, like one on top of each other, they're supplementary, so they add up to 180 every time. So 90 and 90 is 180, you can tell that. But it's also the same with these two. Like these are one on top of each other, that's 180. It only works this way, okay? Same with the square, same with the rhombus. Let's keep going. Same with the rectangle and the parallelogram. They always add up to 180. That's a cool property because if you know one of them, right? If you know one angle, you can just subtract it from 180 to get the other one. Okay, so make sure you know that. And now we're going to do some exercises here. You'll have to write stuff down here. So we're going to go to page 193. We're going to skip a little bit. Don't worry what's along the way. So page 193 looks like this. Okay. So it says find AC. Right? So when they do that, when they have those two letters, they're asking you, right, the distance between A and C, right? So that's what they're asking for. Find AC, find angle A, so they want this angle here. And they want angle B, which is over here. So that's what they're asking. And they also want you to tell them what type of quadrilateral is ABCD, right? So name it, right? Name it. That's what they want. Name it. Now, you should probably recognize that, right, this angle is the same as this angle, right? And it has one pair of parallel sides. So why don't we name it first, right? One pair of parallel sides, base angles are equal, right? So these are properties, and it does look like a trapezoid right off the bat. So this is actually particularly between the right trapezoid and the isosceles trapezoid. This is definitely an isosceles trapezoid. Okay, it's an isosceles trapezoid, so we have named it, right? We've answered the question, what type of trapezoid is it? So we kind of did that first, and that's what I would actually encourage you to do first. Like what shape are we looking at? Okay, it's an isosceles trapezoid. What do I know about it? I know that this angle and that angle, they should add up to 180 degrees. We know that 60 and this, and you can probably already tell that that's going to be 120, right? But just to show my work, I'm going to say angle A is 180 minus the 60. Angle A is equal to 120 degrees. So there's that. Same thing here. These two should add up to 180 as well on this side. It's true on this side as well, right? So angle B is also going to be 120, but I'm going to show my work anyways, just to not get too complacent. It's always good to show your work, right? You write an essay, you make a point, right? You use the appropriate language and you develop, right? You show how you got to your answer, right? To your conclusion. So there's that. So we have angle A taken care of. We have angle B taken care of. We have named it. Now we need to find AC. And because it's an isosceles trapezoid, we know that this is going to be the same as that. We're going to say stretch AC is going to be the same thing as BD, which is 4 centimeters. Right? So I'm just showing you how I got there. I'm looking at the whole picture, and I know that this is going to be the same as this. Mr. Dirksen, how did you know that? Because of the base angles being the same, I knew it was an isosceles trapezoid. So right away I go and look at that. Okay. That's the answer to that. We've answered that. Now it says here, find WX. So they want this side here. Let's put a question mark there. And here's the angle notation is weird, right? Here's the three letter notation for angle. So angle X, Y, Z, right? Where is that? Where is angle X, Y, Z? Focus on the Y, right? Put your attention on the Y, on the middle letter, and that's going to be where they meet. Okay, so it's Y is right here, but let's read it the way they're writing it. X is up here, X, Y, Z. They want this angle right here. Right? So they want that angle, this whole thing here. That's what they want. And so we're going to call that, this is the same as that. Why? Because this is a kite, right? We know that these angles are opposite and it's going to be 101 degrees. I'm just going to put an arrow to this whole thing. That's why they use the three-letter notation. Okay, pay attention to Y, because angle Y actually has two sub-angles in it. So they have to tell you it's like X, Y, Z. It's the whole thing here that they want. So that's 101 because we see 101 on the other side. WX is going to be 2 centimeters, same as XY. Okay, so we know because this is a kite, we know that these two are going to be the same, and we know that these two are going to be the same. Okay, so I'm adding some labels to it, and it meets at a 90 here. So this is a kite. If they ask you for the type of quadrilateral, which they don't, you just say that's a kite. Okay, and this is where it gets. This is complicated. What's the sum? The sum of these two. Let's see what they mean. WXY. WXY. That's this one up here. Right? Maybe I'll do this. I'll use a highlighter. This angle, they're talking about this one up here. And YZW, YZW, this angle right here, they're talking about this down here. So what would the sum of these two be? What would it be if you had to add them up? So sum of WXY, angle WXY, and angle YZW. Okay, I'm going to write it down again here. Okay, we know that the sum of all angles is 360 degrees. That we know that. Like all four angles added up together would be 360. Therefore, what they want, right, the sum of the two angles would be 360 minus 101, which is this one, minus another 101. Okay? And that would be, sum is going to be 158 degrees. These two angles here would add up 158, which is what's left over if you take away the 101 and the 101, right? If you take away those two, you're left with 158. We don't know what they each measure individually, but that's just it. We're going to add a C to this page. Because you're gonna need to know how to do this. Find the height. So this is C. I'm just adding that on page 193 of the shape in question A. And we're gonna quickly redraw that because I want you to see it on your. We know that this is 4, this is 5, this is 9. This is 5 centimeters, 9 centimeters. This is 4 centimeters. And the height of this would be anywhere from the top straight down to the base. And I'm going to strategically do that over here. This is the height right here. Put a 90 because it has to make a 90 with the ground. So we're going to have the height drawn out as a right triangle. This is height, not the hypotenuse, okay? It's the height. This is 4 centimeters. This is going to be, how would you find this sliver here? Well, if you think about it, let's also draw a height down here on the other side. This is also the height. If you go 9, right, 9, the whole thing, take away 5, that stretch up here, you're taking away that middle piece. And if you divide that leftover by 2, you're going to get what these two stretches are over here. Okay? So to get that piece, you go 9 minus 5 divided by 2. The top needs to be in brackets, right? That's 4 divided by 2, which is 2 centimeters. And that's what that is going to be, 2 centimeters. I go 9 minus 5. That leaves me with what these two stretches should measure combined. That's why divided by 2. That's very important. And so use Pythagorean theorem here. H squared would be 4 squared minus 2 squared. Right? If you don't like calling this H, call this A, right? Some of you like to, you have your ABC for Pythagorean theorem. This would be A in this case. So H is going to be square root of 4 squared minus 2 squared. We can do this in our heads, right? 16 minus 4. H is going to be square root of 12. Find my calculator. Packed everything away. So it's square root of 12, which is 3.46 centimeters. That's the height of that trapezoid. So that's going to also find its way into what we're doing. It's rough, right, to do this on a Monday after spring break? No. All right, so here on 194, you're going to have to copy things because the textbook does a pretty poor job at having some good questions that follow this. You're supposed to know this. So on page 194, I'm going to start writing at the top here. And I'm going to ask you to write down classify the following state two properties of each. So I'm just going to draw, right? So A There are the 4 shapes that we want to classify. All right. So the first one, I'm just going to first state the properties that I see, right? All 4 congruent sides. And don't worry about using your own words. All 4 sides are the same. All 4 sides are equal. That's fine. And you can say 2 pairs of parallel sides. Can you say that this is a square? It kind of fits the, right? It has 4 congruent sides, 2 pairs of parallel sides. Can you say with 100% certainty that this is a square? You would not be able to say that. First of all, it doesn't look like a square because it's slanted, right? But also you don't have the 90-degree markings, right, on the corners. So this is a rhombus specifically. Okay, if you said if you said a square, this would not be right. Right? Therefore, a rhombus. So you have to be specific as possible. Okay, to get the mark. Okay, here we have 1 pair of parallel sides. We actually have two right angles because we know that if this is 90, right, these two add up to 180. We know that this is 90 as well. So that was added later, but it doesn't matter, right? 2 right angles. Therefore, this one is a right trapezoid. And it's easy to identify that one. It doesn't look like an isosceles at all, right? So out of the trapezoids, it would just be the right trapezoid. This one, you can tell it's a kite. It's also easy to identify, right? But we're just going to say it has 2 pairs of congruent sides. I need you to also go the other way. Like if I ask you to draw it, you're going to have to make markings like that. 2 pairs of congruent side, and you could say diagonals are perpendicular. 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 They meet at a 90. It doesn't really show you the this is bisected. We'll just say this is a kite. And here you could say 2 pairs of parallel sides, diagonals bisect. You could not say with 100% certainty that this would be a rectangle. There are no 90-degree markings, right? But the diagonals do bisect. If it would be a rectangle, all these would be the same as well, right? So this is a parallelogram, therefore parallelogram. I think now I'm going to ask you to go to page 200 and do 200 to 202. using what you've learned, right? I don't think I covered like every single scenario, but using your knowledge, go to page 200, do page 200 to 202, and then we'll go over that tomorrow, and be ready for an AC of some sort based on what we learned today.